Welcome again to another edition of the Southwest Climate Podcast. Mike Crimmins, how you been? I haven't seen you in a while.
I'm good. Yeah, it's already March. I couldn't quite get my head around that. I'm already feeling monsoon season.
I'm not there this month. Normally I would have run with that. We've got a lot to talk about with the winter.
It's true. It's not even close.
We are, by my estimate, we're somewhere in the vicinity of 70 to 80% of the way through the winter as defined by the total amount of precipitation. So we're pretty darn close to its end.
Wait, if you can finish early? So like if you got to 100% precip, we would just call it good?
No, I mean, on average, at this point in the winter, about 70% to 80% of the total rainfall for the winter has fallen.
Oh, okay. You believe that it'll rain again?
Well, I believe that it'll rain somewhere between, on average, 20 and 30%.
That's my gig.
The point here is it's already March. Hard to believe. It's been rolling right through. And by my accounts, Mike, at least the last month, I'd sum it up in the following way: coldish, windy, and dry.
Yeah.
Those adjectives, I'm not a fan of those adjectives.
You're not glowing about any of those things. This is such a whiner thing too. I'm kind of like ready for it to warm up.
Well, it's been cold though, right? I mean, I'm not imagining that.
We've definitely had some very cool nights, and I think on average it's been a little bit cooler. It's funny though, because this is probably average for Tucson in the winter, right?
Feels cold. Which it really pains me to say that. I came from the Northeast, and even before coming to Tucson, I really enjoyed the winter. But there's something about living in the Southwest that I think makes you a little soft. It's slightly cold-ish, cooler, and it feels cold. I think your body must physiologically adapt.
Yeah, no, you absolutely change. Yeah, I've been here for 20 years, grew up in Michigan. So almost half my life in Michigan, almost half my life here in Arizona. And I'm completely lost all of my cold-blooded or cold weather instincts and abilities.
Yeah, it's like I've gotten hardened to the heat and way more sensitive to the cold, which honestly, is a little bit of an identity crisis for me. So you might have to be my therapist later.
Your weather therapist?
All right. So it's been cold. It's been dry. We've been hoping all along that, we expected, I suppose, that it was more likely than not that we'd see, a dry winter, given the fact that we're about 3/4 of the way through the winter in terms of rainfall and snowfall. But it's going to be hard pressed for us to get near average. As of, the first week in March, Tucson is close to 50% of its average. Phoenix is a little bit more than that. Flagstaff is maybe faring the best. It's still below average, around, let's say, I'm eyeballing these right now, but maybe 80% of average so far. Las Cruces is, 70-75% of average. So in that vicinity. And Albuquerque is kind of the big loser so far of the major Southwest cities. It's only experienced about half an inch, a little bit more than half an inch. And it typically gets, at this time of year, about 2.25 inches. So quite a bit of below average conditions up there. So you were trying to paint this with a little bit less of a dark paintbrush by saying that, well, at least we've gotten rainfall sort of distributed throughout the winter, even though it has been below average. So take us through a little bit of the conditions in the last month, let's say, but you can go back further if you want to, that have led to the sort of cooler, windier, and drier conditions.
Trying to be a little more glass half full on thinking about this winter. We kind of rag on the ENSO forecasts, but they do generally work, right? I mean, we can get some blips here and there, especially for La Niña winters across the Southwest. So knowing that we're going into a second La Niña winter, it just didn't spell great news for the Southwest, knowing that we're going to run into that. I think the monsoon season was such a boon to us, but it wasn't going to solve all of our drought problems. And so having this second La Niña winter really did spell some trouble as far as precipitation. So we were pretty excited about the precip that we got in December. I think that was a real surprise, and that put down some above average precip for some decent swaths. It didn't hit everybody in the Southwest, but I think it really helped. It's kind of early in the season. January is very dry. And then February hasn't been a whole lot going on here. We did end up having two precip events. There was an event, New Mexico got some precipitation early on in February, and it completely left out Arizona. So it's kind of it cut the Southwest in half. Just the way that the storm system moved through the Southwest just favored New Mexico a little bit more. We got to the middle part of the month, and we had another precip event right around the February 17th, pretty light. Parts of the Four Corners area got some precip, high country in Arizona and parts of Southeast, and that was about it. And then the biggest event of the whole month was when we had a pretty deep, cold storm system pick up some moisture off of the East Pacific and dragged it inland and put down a pretty good amount of snow across the high country and decent precip amounts. This was right around the 23rd and 24th of the month. And snowpack shot up in the northern part of the state pretty quickly with that event. That was about it. There wasn't much else going on. A strong ridge across the East Pacific. So there was a trough, there was a kind of an average trough across the Western US, kind of work its way east. It would retreat back towards the West. So it kept us with those average to sometimes below average temperatures, maybe brief warm-ups in between. Largely, these were dry, inland, low-pressure systems that would drop out of the Pacific Northwest, and we could feel it, right? You could feel the air dry out even a little bit more, the dew points fall a little bit more, wind kick up out of the Northwest, and you get that cold air, and we'd had some pretty cold nights with that too over the last month. So just to kind of reiterate what you're feeling there is, it's been pretty dry, cool, and windy for the last 30 days across much of the Southwest.
And there you have it. Southwest climate outlook.
It's not even the outlook, it's the hind look.
Well, we can make that the outlook, I think. Was there anything unexpected about the weather here that maybe caught you by surprise? Or, now that you've been, 25 years here or thereabouts, like this is sort of, it feels a little bit like a ho-hum kind of normal-ish, slightly below normal-ish season so far. Not unexpected. There's no, we haven't tilted one way or the other. We love the extremes, obviously, because we get something to talk about, but, it just kind of feels like a pretty ho-hum kind of winter so far.
Yeah. There's a couple of things that I always worry about going into these La Niña winters, because we've lived through some really epically bad La Niña winters in the early 2000s, where we can end up having a ridge of high pressure, like is over the East Pacific, but it moves inland over the West. It's hot. It's hot like through the whole winter. We're in the 80s, December, January, February, which for Tucson is pretty insane. And then it's very dry too, right? So you got both of those things. So this winter, you get itchy, you got a La Niña coming. So this one, the fact that we had the December rally of precipitation is, kept it out of the worst case scenario. And the fact that temps have been somewhat moderate, I think, has helped with snowpack ever so slightly, which is still not great anywhere. Right? I'm trying to paint this again. This season's going to be in total quite dry in many locations, but it won't be the driest on record, and it certainly won't be the warmest on record. So isn't that sad that that's all I can kind of scrape together? Yeah,
but I have at least a counterpoint to that. I hate to bring this up, but I was just thinking, and I only did this for Tucson, and I don't think it's the case everywhere, but I was just looking at, last winter was one of the drier winters on record in Tucson, for example. So looking at the November, December, January, February, March, and April monthly total. Last year, 1.4 inches of rain, right? So that's eighth driest. So this is at the international airport for those 6 months. 2021 experienced 1.4 inches of rain. This year, if in fact we do not get any more rainfall for the next 2 months, which, admittedly is maybe unlikely, but we also don't expect to get a lot of rain. We'd come in at 10th driest in Tucson. So as of right now, the airport's only experienced 1.8 inches of rain. So then the counterpoint, Mike, is if you were to look at these winters, the driest back-to-back winters on record, and if Tucson, Southern Arizona does not get any more rain, we're going to be it's going to come in at the second driest back-to-back winter on record. I feel stupid, like trying to find the extremes to talk about, but I think the point here is that while it's not been a top five, so to speak, dry winter. I mean, when you look at this in conjunction with last winter, the back-to-back winter is pretty bleak.
Yeah, lucky they had the third wettest monsoon in between those. So the double dip La Niñas are never good news, right? For the Southwest, 11, 12 was a double dip, bad for us down here. I do think what makes this situation different is having that monsoon precip in between. And again, that didn't even happen everywhere across Southwest too. So yeah, I'm trying to maybe polish this up a little bit too much. It's not a great situation. As you said, we're into March now. We're running out of time. It's harder and harder as we get towards April to get any sort of meaningful precipitation. We're kind of running out of the core of the season here.
I think maybe it's worth thinking about the snowpack around the Southwest. And obviously that sort of mirrors rainfall, but I guess there's something that's surprising to me. So if you looked at the West in general, most of the area, let me call up the map here. So looking at sort of the last 4 months of beginning in November, much of the West, with the exception of parts of the Colorado Rockies and the Northern Rockies in Montana and a little bit in Idaho and the Pacific Northwest. Outside of those areas, there's been below average rainfall and snowpack. And that's also with, a really wet December that had, as you mentioned, had we not experienced those atmospheric rivers in December, we'd probably be having a we would be talking about the extremes, I think.
Yeah, absolutely. Yep.
December is pretty big, but I was looking at snowpack and yeah, it largely mirrors that same pattern. But I think what struck out to me was the snowpack conditions looking at a basin level are not as below average as I would have otherwise thought. Largely parts of Colorado where there has been above average precipitation are near average or slightly above average. But even those places where they experience below average precipitation, it's close to average. And that pattern it's broadly across the West. And I think probably what's going on here is we have just had kind of a cooler than average January and February that has allowed those snowpack that maybe part of it dropped in the early parts of the winter, in December in particular, have allowed those snowpacks to persist. So I think the fact that it has been colder, that trough that you were talking about before has been somewhat, even though it's been dry and hasn't generated rainfall, it's also been cold.
So some of that trough activity has given the Central Rockies a little bit of precip over the last 30 days, some real isolated pockets of even average precipitation. So just like you said, it's been getting some subtle pulses of precipitation, and it's been in an on average temp to cooler than average kind of temperature regime, which again, it's really different than we were talking about before. As if we had a kind of a La Niña winter with the ridge over the Western US, we wouldn't have any of that, right? We would have above average temperatures and, zero precipitation for much of the Southwest Intermountain West. So if you're going to do La Niña, this is slightly better, right? And I think the snowpack is reflecting that. I mean, we've seen worse snowpack at this time in the lower and the upper Colorado River Basin. But again, it's nothing to write home about. Every time we get into a La Nina winter, I just like, can it be over with? As we get through it, I just try to like look on the bright side as much as possible.
All right, so you have to help me figure something out. We're going to do this on the fly because I want to focus maybe a little bit on the sort of regional atmospheric pattern, the ridge that we were talking about, and the sort of trough, which are really their position, a subtle change in the position of where these troughs are matter quite significantly. So we've had this trough sort of diving down into the southwest, but it's been driving down inland, right? And so consequently, like you can just envision that as it's moving down, and like cooler air will be to the north of the trough of that wave. Because it's been inland, it's also been dry. But if you were to move that sort of trough westward, right, you're more able to pick up moisture from the subtropics. And so the pattern where these highs and lows sort of prominently feature in any one season is pretty consequential to our overall what the climate ultimately looks like. So then I sort of went into this deep dive into these overall patterns. Like ENSO has a particular expression, but also at sort of a monthly timescale, people look at the Pacific North Atlantic pattern, the PNA, which also has an expression of basically during El Nino events, it tends to look a little bit more like a low pressure system, kind of what we've experienced, whereas a high is focused over the Alaska. And I'm having a hard time, I think, understanding how this Pacific North Atlantic pattern relates to ENSO and vice versa. That's not a very great lead-in question.
It just does, Zach.
It just does.
So you led with this idea of the Pacific North America pattern, right? And so these are modes in the atmosphere. They're patterns in the atmosphere that tend to show up on weather maps, discernible patterns that show up on weather maps more frequently than not, right? So if we think about looking at daily weather maps, you could assume that there's no repeatable patterns, right? That it's just constantly moving and it's all kind of crazy chaos and there's no repeatable patterns. But we know from research going back decades now that weather's noisy and those daily weather patterns certainly do continually move around, but sometimes they can get stuck in certain patterns that repeat themselves, right? One of those patterns, given its name, the Pacific Ocean and North America, is called Pacific North American pattern. And it's a pattern that is, if you were to kind of look at a weather map, you'd end up seeing in one phase of that pattern would be a strong low pressure system over the North Pacific, right? We call the Aleutian Low up by Alaska. And then when you have a low pressure system, then typically what you'll see is, especially if it's a strong low pressure system in the upper levels, you'll see a ridge on the other side of it, right? So you get a wave pattern that dips to the south, rises to the north, and that would be over kind of Western North America and Canada. And then that wave pattern continues across the Northern Hemisphere. So it's strongest from the East Pacific, North America, and then there's typically a low pressure system over the Southeast US, right? So that is the positive Pacific North America pattern index, right? And so we can give it a number. And so when the weather pattern looks like that pattern, the daily weather pattern looks like this average pattern, we can give that an index number. And so if it's positive, it's more correlated with that pattern. And then it can flip around as well.
So let's hold there. So under that pattern, the low around the Aleutians and the high intermontane west, that is a pattern that favors what for us? Favors dry and warm?
It's kind of weird because the pattern, the centers of action, right, of the pattern are really up over the North Pacific, and then up over, there's sort of a strong connection to the Pacific Northwest and up over Canada, and then the Southeast US too at the same time. So in this particular positive pattern, the Southwest can actually end up having wet conditions. And so the positive PNA we tend to see more of positive PNA patterns during El Nino winters. And so what that is we also call split flow. So there's a real strong meridional mid-latitude jet, but then there's also typically a strong subtropical jet underneath that. And the subtropical jet is underneath this positive PNA pattern that would funnel in those really wet storms during an El Nino winter.
Right. But we haven't had a split jet.
No, we have not. We have not seen many, if any, splits this winter.
But we have had this positive phase being more persistent this winter since the new year than not, I believe.
Right. And it's weekly positive. So this is the thing about indices that is imperfect, is that when the daily weather patterns don't really match the index very well, like there's other stuff going on, the index values are usually weak. So it's hard to interpret them when they're low, right? It just means that they're not, it's like a low correlation, right? But
right. Okay.
You pointed out in December, we actually had an extremely negative PNA pattern, which is the opposite, right? So that would be
tell us about the negative pattern.
Okay, so negative pattern would be a strong ridge of high pressure over the East Pacific, reaching up into Alaska, a broad trough of low pressure system across the Western US, and then a ridge over the Eastern US. That syncs up with the couple of those wet spells we had across the Southwest in December, right? Because we did end up having a series of deep troughs of low pressure system, but they were deep enough that they actually, and their position, that they reached into the Pacific and were able to pull some moisture up into the Southwest. So that's where you can get like a La Niña winter, which tends to have more negative PNA events, actually give you some precipitation.
If you were doing a summary, let's say a climate summary for a month, and you wanted to sort of get a quick look at what you thought the weather, before looking at precipitation and temperature, let's say, would you look at this pattern? Would you look at the Pacific and try to understand, because it's going to tell you, generally speaking, where those highs and those lows are, right?
Yeah. It's shorthand, right? It's shorthand for, if you had a global weather map, right? It's hard to describe that, right? And so it's just using these indices as a way of shorthanding a pattern that you see that would have some sensible weather impacts on a particular region. And as we were talking about earlier, the Southwest, the PNA isn't a perfect way of describing the weather we would see during the winter. The correlation between PNA and the weather in the Southwest is not super strong. It does lean in certain directions, but it's not like the index doesn't perfectly linearly correlate with the precip that we would see, in any given month. So you'll see, I don't know if you've ever looked at them, but it used to be the National Climatic Data Center, is now the National Center for Environmental Information. Every month, they will write up a synoptic discussion for the previous month, and they talk in terms of indices, right? And so that's, if you go back to December, the 2021 December discussion, the key drivers for the month for the continental US were La Niña and a negative PNA pattern. That's what they're talking about.
All right. So then they go back to my lead-in question for this, but the relationship between ENSO and PNA, there is a relationship there. And I think like what I was getting confused with today is that this PNA pattern is an expression that has a pretty high variability. Like it can change week to week or by week to by week. It's largely picking up more of a weather timescale, whereas ENSO is slower moving and it's more on a seasonal timescale. And so there's a little bit maybe of a different, climate versus weather kind of thing that I was confusing, but they are related, right?
Yeah.
So ENSO tends to nudge the P&A into a particular state, but it's not a very strong nudge, right? You're looking at me a little bit with googly eyes.
No, you're spot on, right? And it's just like you were distinguishing. It's P&A is an index calculated on daily weather maps, largely, and ENSO is a very slow-moving sea surface temperature pattern anomaly-driven phenomenon, right? So it's when we think about El Nino Southern Oscillation and La Nina versus El Nino, what we're looking at is we call like heating anomalies, right? So it's where the warm water is, the unusually warm water is across the Pacific. And where that warm water is going to drive thunderstorm activity, or what we call anomalous convection. And they're big clusters of thunderstorms at the equator. And where those are and where they're unusually active starts to impact the weather patterns in both the northern and southern hemisphere. And ENSO is a movement meridionally, right? So it's from east to west across the Pacific Ocean from El Nino to La Nina phases. And so where that heating anomaly is going to then impact the mid-latitude jet stream in the northern hemisphere on average through the whole season, and then can nudge the atmosphere over time to get into these preferential patterns, right? Like P&A. But there's other stuff going on too, right? Because that heating anomaly, it's not a monolith and it's not a block that shows up every day. We have things like the Madden-Julian oscillation, which can enhance that or destructively interfere with that. And then there's all sorts of other things going on in both hemispheres, weather-wise, internal variability, and then just sort of the chaos in the system, upstream effects that will translate downstream. So I think to your point, the phase of ENSO, La Nina or El Nino tend to push the atmosphere or nudge it slightly. Push is probably too strong of a word, right? Nudge it slightly to end up giving you more kind of P&A positive events or P&A negative events. But even like we saw this winter, you pointed out, December was very negative P&A, which is very La Nina. And then January was actually kind of weakly P&A positive. So it wasn't quite the canonical thing that you'll see. So it'll be interesting to look at the average P&A over the December, January, February season. It probably will be slightly negative just because the values in December were so negative. And then the pattern will hold true. So I don't know how satisfying that is.
No, that was cool.
It's the weather versus climate timescale thing we're dealing with.
Yeah. And it was cool because I always like to think about these teleconnections through like, well, what's the mechanism, right? So you've got El Nino you've got La Nina, like sort of like associated with sort of a westward, more focused area of convection, and so as that convection is more west in the tropical Pacific, that's where the rain is, and that rain is injecting a lot of heat into the atmosphere, which then sort of influences the position of this Pacific jet to its north, like that's streaming out of like Japan, right? And it causes that jet stream to actually the position of its strength to actually move westward, right? Which then has a downstream effect on where this high pressure area is. That's part of how we describe the Pacific North American pattern, right? So it becomes, because of that westward retraction of the jet stream, this position of the high pressure forms more often, off Alaska, off the Aleutian, right south of the Aleutian, but also into Alaska. And so, yeah, you can see how all of these things sort of relate. But I think to your point also, there's a whole bunch of other things going on. So I was just pulling from a recent paper, 2019 paper by a number of Chinese authors from the Journal of Climate, says contrastive influence of ENSO and P&A on variability and predictability of North American winter precipitation. And, they sort of note that the relationship between ENSO and PNA, the statistical relationship. ENSO is sort of influencing only about 29% of the variability of PNA. So it's not a trivial amount. It's quite a bit, but yeah, there's a whole bunch of other things going on as well.
Yeah, and it's a way of trying to connect because we can only, the forecasting part of the seasonal forecasting is that the sea surface temperature anomalies are huge and slow moving, right? So that you can anticipate where they're going to move and how they're going to evolve over long time periods, right? And then you've to get to what's the precip going to look like in the Southwest 6 months later in the winter is all about weather. So it's going to be these events. And so that's kind of a link, right? Is that if you can understand the PNA pattern connection back to ENSO,
exactly,
it's going to give you this little bit of a lean towards, okay, well, if we do get into this PNA positive or negative pattern, it's going to give you a tilt in the odds towards this kind of sensible weather versus this, but it's not going to be perfect, right? And that's where we get into
what's so far off
anomalies and that kind of stuff.
I mean, that's what I think is amazing. It's just we're talking about changes that are happening both in the ocean, on the ocean surface, and the atmosphere in the tropical Pacific Ocean that is bridged through these mechanisms of heat transfer in the upper atmosphere and these fast moving winds, in the jet stream that's ripping off of Japan, and that manifest into, higher pressure areas and lower pressure areas all the way into the Southwest, which are directing storm tracks.
Yeah,
and
absolutely.
It's just really fascinating to see how all these things link. And yeah, you're like over thousands of miles and chaotic atmospheric system. Like you can't expect there to be perfect conversion. Yeah, it's just amazing. I always find that interesting. I always try to think about what's actually pulling the strings as opposed to just the abstract indices that PNA describes or that ENSO describes. What's the physical reason for those patterns to emerge?
During the winter time, which you're kind of pointing out, is that we got these heating anomalies at the equator. The northern hemisphere is cold, right? So there's a sharp temperature gradient from the equator to the poles, and it's actually further south than it would be during the summertime. And that's what gives rise to the jet stream pattern that emerges over the West Pacific. And like you said, too, is that temperature gradient can extend or retract the jet position. And then the wave activity that occurs downstream is what impacts us. It's the same kind of dynamics when we talk about in the fall, when we see typhoons emerge in that area. And they get absorbed into the jet stream and they create the really crazy wave patterns that we'll see in late September and October. So it's why we have to look all the way across to the other side of the world and pay real close attention to that because it ends up coming downstream.
All right. So that sort of alludes to what we think about, the next couple months, as we wind down this winter, all of our rain in the Southwest largely comes, before the month of May. I mean, maybe we get a surprise in May, but waning possibilities here for precipitation. We're probably locked into a drier than average winter for the most part, but there's, still some wiggle room as to how dry we actually get. And so La Niña it's crystallized. It's in the books now, 5 consecutive 3-month overlapping months of below average sea surface temperatures, which is the NOAA definition for making it in as an official El Nino or La Nina. We now have had a La Nina event, a back-to-back La Nina event. It was weaker, Mike, than last winter's La Nina.
Which is pretty typical with double dips.
Yep. Double dip. Second one tends to be less strong or weaker than the first one. So that's following, the pattern. But Mike, are anything on the horizon that can change maybe the outlook?
No, no. The La Nina, as you mentioned, it's waning. But even if it was over today, the atmosphere still takes a couple of months to catch up. And we're also moving into our climatological dry season down here because the jet stream starts to retreat north with the higher sun in the northern hemisphere. Storm track retreats north pretty quickly over the next couple of months. So we're just running out of time. And I think, like you said, we're probably locked into here. The outlooks for the next 2 weeks, 3 to 4 weeks, 1 month, and 3 months, all solid, increased chances of below average precipitation. Doesn't mean we won't get another like stray, precip event, but it's probably not going to be a run of 5 of them, and it's not going to be anything that provides much catch up.
So the monsoon, then we'll look for relief in the monsoon, or
I'm feeling it, man. I'm feeling it.
There you have it. It's going to be probably a dry winter, maybe a cooler than average winter too. I mean, maybe that's part of the story. And I think the snowpack conditions aren't as bad as it otherwise could have been if we would have actually had that high pressure ridge more centered over the area, and so maybe that's a little bit to take away, a little optimism to take away. So we'll have to see how that plays out in the next month or two. But
do you really think cooler than average winter?
No, I don't think, actually.
I'd be really impressed.
It's possible,
but I don't know, man. I think it would have to be epically cold the rest of this month, and the outlooks actually put us right back above average here too. So
it wouldn't have to be epically cold, I don't think.
You don't think so?
Well, where are we currently in terms of average? All right, so I've got the November through February temperature departure. I think you might be right. So
Arizona's February anomaly was 0.3 degrees below average. This is what I'm saying, is when the temperature is average here, it feels cold because the trend has been so strong here.
Yeah, and I'm looking at the November through February map, and 90% of Arizona has been 1 degree Fahrenheit above average, and some areas, particularly like the higher country, have been 3 to 4 to 5.
So the official ranking for Arizona, November through February, it was the 7th warmest.
November through February.
3.3 degrees.
What about the last 2 months?
The last 39th warmest, 1.4 degrees above average.
Yeah. It's funny though, if you were to look at that in the last, let's say, what's the ranking in the last 20 years, right? I mean, like part of the problem with this is that we're looking at it in the context of a very changing climate.
Yeah, it's great.
And so all of these recent winters will be much above what they were sort of in the early part of the record. So the rankings, but I'm just curious, like, has February and January, it's probably been cooler than it has been, in the last 10 years during those months.
Yeah, I totally agree with you on that.
But there's a subtle point here. We're maybe arguing about like a half a degree Fahrenheit or maybe a degree Fahrenheit. But when we're talking about snowpack, that actually really matters quite a lot because it changes the average position of the snow line.
Yeah.
Like that 1 degree Fahrenheit change can lead to, let's say it's 1 degree Fahrenheit cooler, quite a bit of area that has snow on it compared to if it was warmer. So
Arizona's February temperature was probably the second coolest in the last 10 years.
And I bet you January and February together was maybe even close to the coolest because they were both below average.
No, interestingly, January and February, second coolest in the last 10 years or so. So it's actually 2019 was cooler, which is interesting. I don't quite remember that.
It's not going to be a cooler than average winter. You're right. You won, Mike. All right.
That's all I come here to do.
Is that what you wanted?
Why else do we do this?
You feel good about yourself now?
I do. I need to bring somebody down and feel good.
All right. So maybe we'll come back, in a month, and it'll be a good time to sort of recap where we stand with respect to fire, because that's the sort of next major season that we're moving into, and the heat season. The
water situation in the Colorado is not good. so we're gonna Well, we can talk a little bit more.
It's probably worse than the Rio Grande too.
Yeah, I think that's probably right. The Arizona situation, the snowpack is not great either. Some of the smaller, like the Salt and the Gila, are not good. And there's been quite a bit of reporting too, which you know a lot more about than I do. But like the levels in Lake Powell are getting really close to Deadpool, cease of operations. But again, this is ahead of the inflows from this season, so it'll be interesting to see what that looks like later this spring.
Yeah, maybe we should just recap a little bit of the stream flow for the Colorado, but the stream flow forecasts, are calling for about 75% of their average. So that's a pretty bad situation, but they're lower on the Rio Grande. So I think, it's funny, people pay most attention to the Colorado River, but the Rio Grande is like persistently running at like really low stream flows. And it's a much less prominent, I think, river, but
critically important.
Similar issues as the Colorado River.
No, I completely agree. Let's try to spend a little more time on the Rio Grande in kind of a future podcast, but kind of pick apart the water situation a little bit more.
Well, and let's start out with a tour around of snowpack around the Southwest and to the north, because April 1st is sort of the key date, and we'll be just after April 1st probably when we give the next podcast. And that April 1st is historically like the peak of the accumulation of snowpack in the mountains. And so that's from then on, if you look at the hydrographs and the cumulative snowfall, it sort of falls off. So we'll do a tour around different basins about what the conditions look like then. We'll start it off with that, Mike.
Sounds good.
All right. Well, enjoy yourself.
Thanks, Zach. Good talking with you.
Oh, thanks for pulling up. I was a terrible lead into the P&A, man. I don't know.